All right, so let's first start out with some of the things I want to highlight in C# 11, part of the .NET side. And I'm not going to talk about all the different features. Again, we're thinking from an architectural perspective. These are the big things. If you're running a software team, you want to equip your engineers with certain patterns, certain technologies, certain decisions, so that they can be world class. And so, highlighting a few that fall into that category. This is one, the required initializers. You can see on the screen the required keyword, where like last name, you can get it and you can set it only on initialization, only on the constructor or only on the initializer statement. And the compiler cooperates. If you mark that as required, then you cannot use the property initializers unless you initialize last name as well. So across the board, across your entire code base, you're going to see a lot of simplification, because if you needed to require some of these parameters, then you had to use constructors everywhere, and you didn't have the flexibility of using property initializers. And so now you do. And so you're going to be able to simplify code just a little bit more. So that's one of those little things that is, in my opinion, is going to have a pretty significant impact across all of your code base for data transfer objects, for commands, command objects, query objects, event objects, all those simple little objects that carry data, including your entities that are persisted to storage. So that's one feature. The next one is absolutely huge, and this is static interfaces. For the longest time, interfaces only could include instance methods and instance properties. You could not have any kind of static. And so when you had, therefore, there was no global abstraction. You have like int.parse. Well, parse happened to be on int, it happened to be on decimal, it happened to be on short and ushort and all kinds of primitives, but that was just a naming convention. That wasn't actually an abstraction. Well, now you can literally create an interface with a static abstract parse method. And if your class implements that interface, then it also has to implement that particular static method on the type itself. So interfaces have now been elevated from just instance ramifications to the entire type, both static and instance. So that is huge. That is absolutely huge. Okay. And by the way, I'm going to go into this a question. Nicholas, what's your experience with the cost of ACA? It seemed to me that ACA, Azure Container Apps, was kind of expensive. All of the Azure services do have a cost, but and I don't think the dust has settled on it, but Azure Container Apps is very much in line with the cost of app service for what you're going to get for the different cost. However, the huge difference is if you have periods of seldom use. For instance, if you have departmental applications where your employees are the ones that use an application and very, very little usage happens in the middle of the night, you can scale it down to absolutely idle and save a lot of your money, instead of leaving your app service server running all the time. So a CPU in Azure is going to cost what it costs, and a gigabyte of RAM, of memory, is going to cost what it costs. But Azure Container Apps lets you save by giving you the power to be more granular with how much you have provisioned at any given time. All right, so I hope that answers your question, Nicholas. I appreciate you putting that in the Q&A. Okay, another C# 11 feature is pattern matching with I number of T. And well, pattern matching is, they've put that out in 10, but it's been enhanced with these different interfaces. So I number of T is new for .NET 7, and it means that you can create all kinds of numbers. For example, day of the month or day of the year. That's a very specific number. It's you think, oh, it's kind of based on an integer, but it can never be negative. So then you might think, well, maybe it's an unsigned int, because unsigned ints can't be negative. But it also has a much lower upper bound. Well, you could drop it down to a short, but the upper bound of a short is not what you want. You want 365. So you can make your custom numbers, and you can have a richer type system and have the framework treat, and the syntax of C# treat it like a number. And so there are so many developers out there, and the number of developers has basically doubled every 5 to 7 years for the last 20 years. And so early discussions with .NET came out about it being an object-oriented language and all that. What has ended up happening is the .NET framework itself and all the libraries, yeah, those are object-oriented, and some of the libraries implement abstractions better than others, but developers don't universally leverage the power of object-oriented concepts uniformly across our industry. And so this is one of those niceties, one of these abstractions, along with static interfaces, that makes it super, super easy to create your own very specific number types. And when you're using pattern matching and enumerating and creating switch statements and whatnot, you see that anything that you have, like day of the year, which is basically 1 to 365, you could have literally T.0, and you could iterate over, and you could do addition, all kinds of stuff. So that, I think, is going to have some pretty interesting ramifications, because all of us have numbers in our code bases where we're using kind of a regular generic type, and then we're just having logic and exceptions and methods that try to give some constraints about its bounds and how it can be used. Well, now we can create a custom number type that has all of that baked in, and then the rest of the application has less duplication, because it's using a first-class type, not a int that's kind of wrapped with some constraints. Okay, last C#11 feature that I'm going to highlight is string literals. And this is something that can simplify the code bases quite a bit, and it'll probably cause you to amend your coding standard, and you'll look for these when you do pull request inspections. But when you create a string literal, you've been able to do multi-line string literals for a number of years now, but you see the multiple quotes. Well, if we use tabbed indentation for a string literal, then that was actually part of the string literal. But by the number of quotes we start the string literal with, it lets the compiler know to ignore a certain number of spaces or tabs. So you can see the little gray line up and down. That's Visual Studio giving the hint that up until that point, these are going to be ignored. So the open the less than sign element, that's going to be the first character in the line, because we have 4 quotes. And if I wanted to indent that one more, then I could start it with 5 quotes and end it with 5 quotes. And so a lot smarter string literals, so that you can indent it with the method body. Again, this is for readability of the people that are going into a code base and quickly scanning the code, looking for an understanding. So that one right there is super nice, because string literals have been clunky for a long time. And so for those of you who lead or manage a software team, this is one to kind of get your people trained up on and start using it. And that's another element of simplification.